In this video, we are going to go over all the general rules that you should have found after doing your exploration in GeoGebra with the transformations of functions. So this packet, all of your general rules, you should have been using the proper terms of translate, shift, which is shifting, left, right, up or down, reflecting, which is a flip over whatever it may be, x-axis, y-axis, vertical stretch and shrinks are referred to as factors, and horizontal stretch and shrinks as well as factors. The first general rule after part 1 is looking at part G. You scroll down to part G. You should see that in general, when we added or subtracted to a particular function, right, and you use the slider to move it, in part 1, where f of x, we are adding a c value. This means that you actually translated the function, the original graph of f of x moved up. Right? We translate the original graph up c units. You added to y. That happened because f of x is y, and now we're adding to that, so everything is going to go up. In the second part, your translation of the original graph of f of x, this one goes down c units, okay, because you are subtracting to c. Right? So we have up and down. What does that mean? Well, if we have a table of values, on this side, we are going to add or subtract to the y values. The next part, part 2, you are exploring, well, what happens when you added or subtracted to x? Did the same thing happen? And you should have found out in part G that absolutely not. The same things did not happen. What happened when you add to x? You actually went left, and we subtracted from c. You should have found that we actually went right. What happens is you actually did the opposite of what was there. So now when we translate the original function, this one goes to the left c units. Right? If we add 2, we're going to go left 2. If we add 7, we're going to go left 7. And when we subtract, we do the opposite as well. We subtract, we're actually going to go to the right. Okay, this proper notation to explain what is happening is very important as we move forward with what we are doing to describe what's happening. So if you notice, if we add, again, we add to to x, we're going to go left. If we subtract from x, we are going to go right. So our motion actually disagrees with the sign. With our table of values, if we're going left and right, we are actually talking about what's happening to x. So we add or subtract to the x values. Okay, these are our left and right shifts. Part 3 looks at what happens when you make your function negative. Right, so negative f of x. What happened every time you did that? Our summary is now in part C. When we look at that, when we talk about a negative in front, it is a reflection. So we reflected f of x over the x-axis. I don't know what happened. Okay. So when we reflect over the x-axis, we are looking at what happens on our table of values. Well, going over the x-axis is really changing what's happening to y. Because if you're a positive x, you become a negative x. If you're a negative x, you become a positive x. So what happens is these change the sign of your y values. Right? If you're at a positive 2, you go over the x-axis, you're now at negative 2, right, on the y values, reflecting over the x-axis. Okay, the next general rule was, well, what happens when now we make x negative? And we explore in part 4 when x is now negative. So part C in part 4, our general rule is to, again, another reflection, but this time we reflect over the y-axis. So going over the y-axis means whatever you had as a positive x value of, say, 2 became a negative x value of 2. So this reflection changes the signs of our x value. All right, so both are reflections. If you reflect over x, you're changing the y sign. You're reflecting over y, you are changing the values or the sign on your x. Okay, part 5. Part 5, we are looking at multiplying to our function. What happens when we multiply? We put a 2 in front, or a 3, or a 1/2. What happened when we actually put that in front? So this general rule is part E. A transformation that occurs when you multiply a number in front of the original function means, it's kind of different color, means that we've actually either stretched it or shrunk it. So this is a vertical stretch or shrink of f of x by a factor of c. So if you multiply by 2, right, let's say c is equal to 2, then we know that this is twice as tall. Right? We've stretched it like a rubber band. It increases twice as tall. And if it's something like a half, right, then it's half the height. Right? So it's exactly equal to whatever we multiply by. So a vertical stretch or shrink means that on our table of values, we are actually going to take the y values and multiply them by c. Right? So if it's twice, if it's 2, if your c value is 2, again, you would multiply the y's by 2. If it was a half, you'd multiply those y's by a half. So it's vertically stretching or shrinking. The larger the number, more stretch. The smaller the number, definitely a shrink. Okay, moving on to the next part, which is part 6. Now we're multiplying x values. So we multiply our x values. What happens to our graph? Our general rule is going to be this last part, part E. The transformation when we multiply a number inside means that this is now a horizontal stretch or shrink. Oops, shrink. Okay, and this, though, is by a factor of 1 over c. So it's not the exact number. We are multiplying by 1 over whatever that happens to be. So since it is inside and we're multiplying it by x, means on our table of values, we will take our x values and multiply by 1 over c. And depending, 1 over c would then create either a stretch or a shrink horizontally, right? It's opening either wider or more narrow horizontally. These are the general rules that we came up with, that you should have come up with from the packet. When you refer to any of your transformations, you do need to use the terms we talked about: horizontal stretch and shrink, vertical stretch and shrink, translation left, right, up, down, reflection over the x-axis, over the y-axis. You do need to be very specific with all of these terms. And you now can work on the transformations worksheet.